A quadratic equation can be solved in several different ways. We know that the equation shown is a quadratic equation because the highest exponent of x is 2. That's what makes it a quadratic equation. In this case, we start by dividing both sides of the equation by 3, so we can eliminate the coefficient of 3 from in front of x. Then the left side is left with x squared, and the right side is left with 9. Remember that dividing by 3 must be done on both sides of the equation. After this, when one side of the equation contains only x squared, we can take the square root of both sides. We take the square root because it allows us to eliminate the exponent of 2, leaving only x on the left side of the equation. On the right side of the equation, a plus-minus sign appears. It always appears on the right side when a square root is used in solving an equation, and the square root of 9 also remains there. So on the left side we have x, and on the right side we have plus-minus square root of 9. The square root of 9 is 3, and that plus-minus sign simply means that the solutions to the equation are positive 3 and negative 3. This quadratic equation is solved using what's called a common factor. In both 3x squared and negative 6x, the common factor is 3x. We take 3x as a coefficient in front of the parentheses, and then both terms inside the parentheses must be divided by 3x. This gives us the factored form. 3x is the coefficient in front of the parentheses. It's the common factor, and inside the parentheses is x minus 2. If the parentheses are multiplied out, we should get the same equation as above. And indeed we do, so the common factor was taken correctly. Then we take both factors and set them equal to 0. We solve both equations separately and get x equals 0 and x equals 2. In a quadratic equation like this, one that has an x squared term, an x term, and some constant value, it's best to use the quadratic formula. Before we can use the formula, we need to rearrange the quadratic equation into the correct form. First the x squared term, then the x term, and finally the constant. And on the right side of the equals sign, there must be 0. Only from this form can we correctly identify the letters A, B, and C, because in the quadratic formula, A, B, and C must be substituted in the correct places. Note that no x values are substituted into the formula, only those highlighted coefficients. In place of A, we substitute 1. In place of B, we substitute negative 6 in parentheses. Remember to use parentheses for negative numbers. And in place of C, we substitute 5. Then we begin simplifying the expression. First, we simplify the denominator, then the content under the square root. We get the square root of 16 equals 4. Negative 6 is positive 6, and now we split the solution into two parts, positive and negative. We get x equals 1 and x equals 5. Let's return to the very first example in the video and consider how it can be solved using the quadratic formula. First, it must be rearranged into the correct form, and the x term must also be added. If x isn't visible at all, that means the coefficient of x is 0. It's good to write that 0 times x visibly in the expression, so we can recognize that 0 must be substituted in place of b in the formula. So in place of a, we substitute 3, in place of b, 0, and in place of c, negative 27. Again, we simplify the expression, take the square root, and at the end account for the two different solution cases produced by the plus-minus sign. And so we arrive at the solution. X equals positive 3, x equals negative 3. Finally, let's consider how the second example in the video can be solved using the quadratic formula. It also needs to be rearranged into the correct form. There is no constant term at all, so we write plus 0 in that place. Then we can identify A, B, and C. They are substituted into the quadratic formula. 3 in place of A, -6 in place of B, and 0 in place of C. We simplify, take the square root of 36, and the plus-minus sign splits into two solution cases, giving us x equals 0 and x equals 2.